Sorry.
Okay, the given parallel line L, M and N cut equal intercepts at the transversals P and Q as shown. If BC plus EF equals 3, find the value of A. Okay, where's BC? BC is this much and EF is this much here. Okay, when we add both of them together we get 3. Now that's 2A as well, isn't it?
Yeah.
And this here is 3A. BC is the same as 4A. EF is the same as 6A. And this all equals 3. 10A must therefore equal 3. A therefore is equal to 3 over 10, which is 0.3. Who got that? Boom, well done. Okay, next one, number 6. In each of the following triangles, the arrows indicated show that the lines are parallel. Find the length of the segment marked X in each triangle. Now, the best thing to do regards these ones is maybe to, you might want to label them A, B, C, D, E, right? Just give them general labels, okay? Now, I won't even say you have to go that far, to be honest. Like, it's just basically you look for identical sides and or similar sides. Okay, so what we say is AB is sort of like this one here, isn't it?
No,
well, they start here and they get cut by this line. That's why I consider them similar to each other. Okay. Now it wants me to find out X. Okay. Now X is going to be similar to BD, isn't it? Because they both start at this line here and they end at the same line. Do you see what? Do you see how I'm? Do you see why I'm comparing them to each other? Because they start at the same line and they end at the same line. Okay, that's how you match them up. So you go X equals BD. Now X doesn't equal BD. We know they're different lengths. But when we divide X by CAC, divide X by AC, and it's the same thing as BD divided by, anybody? AB. This means X over 5 equals 3 over 6. Cross multiply X equals 3 times 5, 15 over 6, which is 2.5. Okay. Okay. Tell me what number 2 is. Go on, Brian.
9.
But just tell me how to get it. 6 divided by
4 equals X divided by 6.
6 divided by 4 equals X divided by 6. Bring up the 6. X equals 6 times 6. 36 over 4. 9. Okay. Next one, Dennis. Tell me what to do for this one.
4 equals X divided by 4.
Oh, X divided by 4 is perfect. You just turned it upside down. You're well entitled to do that. X divided by 4 equals? Perfect. What's it now?
X equals 20 over 3.
Perfect. Again. Alright. Okay. 7. Find the length of the line segment marked A in each of the following triangles where the arrows indicate parallel lines. Okay. A over 4 equals, anybody? A over 4 equals? 8 over 5. That means it's going to be, anybody? A is 32 over 5. What about this one here? A over equals 5 times 14. 70 over 12. Is 70 over 12 a good final answer? 70 over 12 is 35 over 6. Okay, A is 35 over 6. Do you get the gist of all these now? Move on. Any other questions that gave you any hassle? Question 5. Now, in this question, okay, PQ and R are three transversals intersecting AB. DE equals EF. That tells you there. GH is 8, but GH also has to equal what? GH is the same as HI, because you know these are the same gap, because it tells you that these two are the same. So that's 8 and 8. JK is 7, which makes this one up here 7 as well. Find the length of HI. Done. It's 8. Find the length of GJ. It's 7. That's it. Done. Okay, guys. We'll pause it here, and we'll get us some. In the given triangle, XY is parallel to BC. If AY is 7 over 3, so it's 7 over 3, but it actually doesn't mean it's 7 and 3. I'll give you an example. This could be 14 and 6. Would it still make 7 over 3 when you divide them by each other? Do you understand what I'm saying? If you divide 14 by 6, it's still 7 over 3. Just because it says AY is 7 over 3, it doesn't mean they're actually 7 and 3. It just means when you divide them, they turn into 7 and 3. What would be another example? I could call that 21 and 6. I could call it 21 and 6 as well, and it'd make the same fraction, okay? Now that that's done, okay, now that that's done, what we're going to do is, remember, AY, black divided by green, which is AY over YC, 7 over 3 equals AB, which is, what's AB, can anybody tell me? 15, isn't it? Now AB is 15 in total. Okay, now we can't do what we did last time, can we? Or can we? Now, let's think of a letter. Think of a letter that this could be.
So you got AY 7.
No. Just call XB a letter. Give it a letter.
D.
What? D. Call it D. If that's D, what does it make the rest of it? What does it make the green line? 15 minus D. Now we're in business. Okay? 7 over 3. Sorry, black over green equals red over blue. Do you got it? So that will equal 15 minus D divided by D. Cross multiply. What do we get? 7D equals, what's 15? 3 multiplied by 15, Brian?
45.
45 minus 3D. Move the 3D over the other side, and what do we get?
10Ds.
Plus 3D, 10D. 10D equals 45. And what's D equal to? 4.5. Okay. Next one. In the given figure, BC is parallel to DE. Okay, Robert, BC is parallel to DE. Find DE. I have to find this one going to this one. Now remember, okay, I have to find AE. Okay, here's another ratio. Red over blue is the same thing as green over black. Oh wait, no, that's wrong. That is wrong. I know what to do with this one. Excuse me. Okay. What we're going to do is we're going to do what we did at the start of the chapter. We're going to do big triangle versus small triangle. Do you remember we did that? Yeah. Big triangle versus small triangle, and this will sort it out. Okay. Big triangle versus small triangle. We're going to have this one is 8 and 12. This one here, what's 8 plus 6? Huh? 14. And this here is DE. Now, how much is 14 bigger than 8? We do 14 divided by 8. And what you get, Brian?
1 3/4.
1 3/4. This means that this side DE is 1 3/4 times bigger than 12. When you multiply by 12, what you get?
21.
21. This means DE equals 21. Have enough of that? Next one, or sorry, AE, we're on next, AE. Okay? And when we do AE, what we're going to do next is get AE. Okay? Now, this is the one where we use our colours, alright? Call this one X. 8 over 6 equals what? X over 7. Multiply up to 7. What do we get? 56 divided by 6, which is 28 over 3. X is 28 over 3. So you can see they're tricky enough, but you can get them after a minute, alright? Now, next one. 16. A group of students were trying to find the distance between 2 trees on opposite sides of a river using pegs, a measuring tape and a large amount of string. 2 trees, okay? What 2 trees are they? This one here? These are the 2 trees. I'll colour them in. There you go, there's your 2 trees there, okay? Now, measure tape and a large amount of string. They align the pegs in a particular way and take several measurements and sketch the diagram. On the diagram, AB are the trees, AB are the trees, C, D and E are the pegs. What way must the pegs be and the trees be aligned if the students use these measurements to calculate AB? Okay, I have an idea. Here's what we're doing. What have we been doing all the way through this exercise? What have we been always doing? Triangles, okay? Now look at this. Okay? If I draw a line straight through all 3. And what if I do it this way? That's it. You're talking about a triangle. Now, the first question is, what way do they have to be aligned? When they're not in alignment, if you look at it straight forward, your 2 pegs will look like this. I'll use a different colour. They're blue pegs, okay? Your 2 blue pegs, if you're looking directly at them, alright, and you can see 1 blue peg here, 1 blue peg. See what I'm doing here, guys? Alright? Now, if they're in line, you move your head, and eventually, if you can only see 1 peg, so basically what happens is, if you can only see 1 peg, this means that they're in line. Because that means they're not in line. This here means they're in line. So you need to make sure that the pegs and the tree, and you'll see the tree in the background. Okay, the tree will be here. Okay, now all of a sudden I have my 2 pegs and my tree. Okay, I'm looking straight at them. Now you got to remember the pegs are before the tree. Do you understand? You're lying on the ground looking straight across. Now, currently nothing's in line. You set your first peg, then the second peg should be directly behind it. Now, this is basically the first peg here in blue. This is the second peg here, and that's the tree there. And when they're all in line, this means that you've got a straight line. Okay? You do the same thing at point C. You're looking at all 3. The 2 pegs and the 2 pegs and the tree. You remember you did this in science with the mirrors. Remember you had to make sure the pins were in the one line. That's basically what it is, okay? Now that's basically what you have to do. Calculate the distance to the trees. How are we going to go about doing this? Distance to the trees, anybody? Remember big triangle, small triangle? Let's see if we can do this. Let me see. Calculate the distance between the trees. 70. We have to figure out what this is here. Okay? Let's write down, let's do big triangle, small triangle again. Okay? Big triangle. And I think I'll make that the small triangle actually. Small triangle, big triangle. Okay? What can we say about both triangles? They are similar because they have the exact same angles.
Hey, good afternoon. Would all teachers please leave their absence to the side door? And just a second piece of information in relation to our students from last year. 3 of our students have received entrance exhibition awards in Trinity for 2013.
Now, you can see that all these angles are the same, okay? So they both have the red angle here, just the big triangle. And then they both have a black angle in the bottom left corner. And then they both have the blue angle in the other side. So they actually are similar triangles. Now, what are we going to do about the length? That's the problem, right? So this one here is, what length is this one? It's x, isn't it? And this one here is 57. The next one is x plus, anybody? X plus 48 divided, and what's on the other side? 133. Now, can anybody give me the ratio here? Can anybody give me the equation I'm going to use next? Anybody at all? This side, x divided by 57 is the same as x plus 48 over 133. Remember, they're the same triangles except one of them is bigger than the other one. Let's cross multiply and see what happens. We're going to get 133x equals 57x. And what's 57 multiplied by 48? Ah! 2,736. Bring the 57 over the other side and what happens? It becomes a minus 57. What's 133 minus 57? Anybody? 133 minus 50. 133 minus 57? 76, okay? So 76x equals 2736. Now what is 2736 divided by 76?
36.
So x equals 36 meters. 2736 divided by 76 equals 36. Now, we've done it. Another group of students repeats this activity. They have a similar diagram, but different measurements. Their measurements are BE is 40. BC is 9 and BC is 9. Let's see, from BE equals 40, BC equals 9. Based on the value of AB that you got in the first group, so AB is still, what's AB? 36. Find what measurement the second group would have got for CD. So this time, this is the value we're looking for. Let's call it Y. Okay, like last time, you're going to write down your 2. You're going to write down all your measurements into 2 triangles again. Okay? Now remember the 2 triangles, okay? How long is the small triangle this time? Look at it. It's this side by this side. What is it? 36 and 40. How long is it from here all the way down? 36 plus 9? 45. And 45 and Y. What ratio do I use this time? Can anybody tell me? 36 over 40 equals? And then, what do we do? I'm going to show you a trick. Am I allowed to do this?
Yeah.
Why am I allowed to do that? Turn both sides upside down. Basically, a half equals 2 quarters. Turn them both upside down. 2 over 1 equals 4 over 2. Is that still correct?
What's the point of it?
The point is I moved the x, the y up to the top. So it means I have to do less moving around. Now we can just bring the 45 directly up. No messing around. Okay? So I can do y equals, what's 40 multiplied by 45? Then divide your answer by 36.
50.
Y this time equals 50 meters. Now,